Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Hari ini kita akan buat review tutorial on chapter 5, Work, Energy and Power. So, Work, Energy and Power dia ada subsection 5.1, 5.2 dan 5.3. Dalam video pertama ni kita akan buat tentang 5.1. Okay, so 5.1 kita tengok the question ada 5 question. Question 1 up to question 5. So, jom kita tengok question 1 dulu. Okay, a 75 kg painter climbs a ladder that is 2.75 meters long, leaning against a vertical wall. The ladder makes an angle 30 degrees with the wall. So ni adalah dia punya sketching lah. Okay, so ladder adalah sini. This part is the ladder. Oh, not that. Okay, so just this part is the ladder. Then you have wall, vertical wall sini. So the ladder makes an angle 30 degrees with the vertical wall. Okay, dia jalan dekat sini 77.25 meters. Okay, so how much work is done by the gravity? Okay, so when you draw the free body diagram orang ni, dia ada moving upward, dia ada force upwards ni normal, weight mg ke bawah. So kita nak cari dia punya work done by this mg saja. Okay, so first things first, when you know this is 30 degree angle between the ladder and the wall, and kita tahu ni macam kotak ni is 90 degree. So the angle here ni yang penting sebab ni angle ni lah akan determinekan in between angle kita nanti. Okay, angle sini bersamaan dengan 60 degree. So 60 degree ni sama dengan the angle of between weight and also the y component ke bawah. Okay, so have mg dengan 60 degree. Selepas tu between angle ke bawah yang itu mg cos theta ni dengan juga kita punya displacement ke straight line. Oops. Okay, sorry, to straight. Okay, straight line situ, displacement S is 90 degrees. So the total angle sini, sini pun dah tulis sini. Okay, the total angle sini adalah 90 plus 60 degree, which is 150 degrees. So that's your angle between the force mg and the displacement is 60 plus 90 degree, which is 150 degree. And then kita punya weight W sama dengan mg. So when you calculate the mass 75 kg times 9.81, you have 735.75 newtons. Okay, so the total weight W sama dengan 1752.24 joule. Okay, when you do the work sama dengan F dot S, which is Fs cos theta, the part yang theta tu sebenarnya kita adalah part theta tu. Mana ke? Okay, ni F dot S, jadi FGS cos theta. Okay, cos theta ni is the angle between the force and also the displacement. So our force is mg, our displacement is over here. Okay, displacement. So you need to calculate the angle here plus here. Kita jangan ambil yang kat belakang ni. Okay, kita ambil yang the shortest distance between our force and also our displacement. Okay, so that's for question pertama. Now for question B, does the answer to part 1 depends on the painter's, or whether the painter climbs at constant speed or accelerate by the up the ladder? If you see you punya equation yang ni, okay, if you see this equation again, it does not depend on speed or acceleration. Okay, it just depends on the displacement and the force. Okay, so no, the gravitational force is independent of the motion of the painter. Okay, it just depends on the displacement and also the angle between the force and displacement. Okay, so that's for question number 1. Now for question number 2. Okay, if you see question number 2 at sini, the figure 5.1 below shows a force F at an angle of 39 degrees to the horizontal, pulling a block of mass 15 kilograms on the floor at a constant speed. Okay, the coefficient of the friction between the block and the ground is 0.3 meters. Okay, so dia punya mu atau sebab dia is moving to the rough surface, so there will be a frictional force. Okay, frictional force ini. Okay, so akan ada frictional force ini. And also force ni pula kita boleh resolvekan dia into the x and y component lah. Okay, so this is what I did. Ada f cos theta dan atas ni ada f sin, ada f sin theta. Kecil tu f tu. Okay, kita ada f sin theta moving outwards and f cos theta moving to the right. And also you have weight downwards and normal upwards. Okay, So ini saya dah highlight dah, moving at a constant speed. When you have a word of constant speed, you should know that you punya acceleration is 0. So the total force is 0 on the x component. So soalan minta calculate the force F. Again, for any type of question involving force, you need to do free body diagram lah. So what I did here, I did the free body diagram for you guys. Okay. So free body diagram again, ada force upwards, F sin theta. Okay, kita ada F sini, so we can resolve it into Y and X. And also we have normal, weight downward, and also friction moving to the left. Okay, then because we know that there's no acceleration on the X component, we can do summation of Fx sama dengan kosong. The force that is present on the X is only F cos theta moving to the right, and you have friction moving to the left. So F cos 39 degree tolak friction sama dengan kosong. So F cos theta ataupun F cos 39 degree sama dengan kita bawa friction to the right. So we have F cos 39 degree sama dengan F, which is equal to mu n. Okay, mu kita adalah 0.3. Okay, this is mu ataupun the coefficient of friction lah, mu. Okay, 0.3 and our normal force. So for this equation, we cannot solve it yet because we have two unknowns. We have the force and also the normal. What you need to do is you need to do another equation. Which equation you should do? You should do the y component punya equation. Again, on the y component, objek ni tak bergerak. So you can do the summation of Fy sama dengan kosong. So the forces that are present on the y-axis is the normal force plus with the F sin 39 degree tolak dengan dia punya weight mg. Okay. From here, we can try to do the normal force as the subject. Kiranya kita bawa dua-dua ni. Kita bawa F sin 39 degree dengan mg towards the right. So kita menjadi normal equals to mg tolak F sin 39 degree. Then this is my equation 2. When I have two unknowns, I need two equations. So now I have my two equation. What do I do next? I sub equation 2 ni, n ni, ke dalam equation pertama. Kan equation pertama F cos 39 degree sama dengan mu n. N yang saya dapat daripada equation 2 ni, saya masuk ke dalam equation pertama. Okay. So bila saya masuk dalam equation pertama kat sini, saya akan dapat macam ni rupa dia. Okay. Oh, sorry. Sini. So kita dapat F cos 39 degree sama dengan mu mg tolak F sin theta. Masukkan mu ni ke dalam, kita dapat mu mg minus mu F sin theta sama dengan F cos theta. So what I did over here pula, saya bawakan komput. Sebab kita nak cari force kan. Ini ada force kat sini. Okay, ini ada force. Allah. Okay, sini ada force. Dan sini pun ada force. Saya bawa this part towards the left hand side. Saya akan jadi macam ni lah. F cos 39 degree plus mu F sin 39 degree sama dengan mu mg. Okay, saya factorize out the force. Factorize out force kat luar. Dan bawa cos 39 degree plus mu sin 39 degree ke bawah sini. So all the terms ada. So you should be able to find the force, which is 45.7 Newton. Okay, simple enough. Okay, so now let's see question number A2. What is the work done by the force F when the block is displaced 0.6 meters along the floor? Okay, so again, kita tahu work is F dot S, which is Fs cos theta. The force tu kita dah cari, which is 45.7 Newton. The displacement is 0.6. So the angle pula is 39 degrees lah. So kiranya if you see here, kiranya kita tahu kita punya displacement gitu. Okay, gitu. So the force dengan displacement. So the angle between the force and displacement is 39 degree lah. Okay, the shortest distance between the force and displacement. Okay, 39 degree. So here kita ada F dot S, which is Fs cos theta. F tu yang kita cari 45.7 Newton. S tu is 0.6. Then kita ada cos 39 degree. So we can find our work done is 21.31 joule. Okay, that is the work done for question number A2. Okay. So now question B ni pula, dia kata the worker then applies a force downwards at an angle 39 degree to the horizontal. So what happened to our diagram? Dia takkan jadi macam ni dah. Okay. So sekiranya instead of force moving outwards sekarang ni, you have the force macam ni rupa dia. Okay, you have the force moving downwards. Okay, you have the force moving downward at an angle of 39 degree. Oh, okay, 39 degree. Okay, ada 39 degree kat situ. Force moving downwards. Then free body diagram ni sama je. You have the normal force upward, weight downward, and frictional force to the left. So force ni, again, you can resolve it into Fx and Fy. Okay, the working pun is really similar to what we did on question pertama. Okay, again, because the block is moving at a constant speed, so Fx equals to 0. So F cos theta, cos 39 degree tu kan ni ke bawah kan. So you can resolve it into Fx dia ialah F cos. So, okay, ni adalah susah lah. Tak nak macam ni. Okay. So ni adalah F cos 39 degree. Dan bawah ni pula, okay, when you resolve it, bawah ni pula adalah F sin 39 degree. Okay. Okay. So F cos theta tu moving to the right, F sin tu moving downwards. Okay. So you have F cos 39 degree, tolak friction. Again, friction is mu n. So you can find our normal force is F cos 39 degree over mu. So kenapa kita buat macam itu? Sebab again, it's the same type of working that we did in question 1. So then, again, sebab kita nak cari force, okay, normal pula kita tak tahu, we do again submission Fy sama dengan kosong. Okay, tengok pula komponen Y dia ada normal, moving outwards, and then we have weight moving downwards, and we also have F sin 39 degree. Okay, so kita dapat normal tolak mg tolak F sin 39 degree. Tapi kita dah boleh, kita ada normal daripada equation pertama kita, so kita subkan normal tu terus. So question pertama tadi kita masukkan normal ke dalam equation pertama. Okay, method kedua ni kita substitutekan normal daripada equation pertama ke dalam equation kedua. So doing that, okay, kita dapat F cos 39 degree over mu tolak mg tolak F sin 39 degree. So you can find the force daripada situ, which is now 75.04 Newton. Okay, so that's for question B lah. Okay, question B kita masukkan normal force ni ke dalam equation yang ini, ke dalam equation ni. So insyaAllah akan dapat force ni lah, force sama dengan 75.04 Newton. Okay, try to calculate it lah. Okay, so for question number B2 pula, what work is done? So again, kita dah find force, displacement dia masih lagi 0.6. So we know that work pula, okay, for question B2 is F dot S, which is Fs cos theta. Cos theta tu is the angle between the force and displacement. Force tu kita dah cari 75.04 times the displacement of 0.6 cos 39 degrees. You should have the work done is 34.99 joule. Ataupun kalau korang tulis 35 ke, it's still the same lah, but 34.99 joule. Okay, so that is for question number 4, nombor 2 lah. Okay.